By the end of today's lesson, you'll have designed your own compliant wheel or squishy wheel that you can make for 3D printing out of TDU. You'll get a better understanding of Fusion's extrude tools, combine tools, and how you might use repetitive patterns a little more efficiently. I'm Mr. Pratt, and I've been teaching CAD and robotics to students for over 10 years now. So hopefully some of the tips that I've been able to help them can also help you get up and started on your learning journey. So today we're going to start by sketching out the wheel here and making a rectangular pattern. And then we'll also talk about making inserts and tool bodies so that you have a hard plastic center with a squishy wheel outer so that as your axle spins to rotate your wheel, it doesn't rip right through the wheel itself. So let's go get started. First thing I'm going to do is I'm going to select my top view down here, and I'm going to create a sketch on the XY plane. This is going to be the width of our circle. So I'm going to go ahead and grab the circle tool. And I'm going to make a diameter, let's say we're going to make a 90 millimeter wheel today. I'm going to go ahead and finish that sketch by selecting the extrude tool or press E on my keyboard. And we're going to make this a 15 millimeter wheel. So now I've got a 90 by 15 mil wheel here. Let's go ahead and actually cut in that centered pattern. So I'm going to go ahead and make a new sketch. And I want to reference this outside geometry inside of my sketch. Instead of just using that outside geometry, I'm actually going to use something called project. So I come up to create and project. What project allows me to do is allows me to grab edges and geometries from other tools. So I'm going to go ahead and project this outside line on. And now I have you notice that for I have my bodies, I now have a purple line showing up. That purple line is really important. I'll show you why. So if I were to go and grab this circle, and I were just to make a 90 millimeter dimension circle, if I were to go back and say I want to make my wheel larger, let's say I want to make my wheel actually 110. If I come back to edit this first sketch, you'll notice that the projected line automatically updated in size, but my dimensionally constrained line did not. So if you're going to be referencing geometries from other faces and sketches, rather than just selecting off of them, I highly suggest that you would project their geometries onto the current sketch that you're working through. Now, our compliant wheel needs some sort of thickness to it. So we need to decide what the outside thickness is going to be. Again, rather than grabbing a center circle diameter, we know that it's 110 and just saying 110 minus, say, 4 millimeters. Rather than putting in an exact dimension, we're going to grab it in an offset. And an offset allows us to work off of this geometry, but we're going to offset to the inside. And I'm going to make the outside of my wheel 4 millimeters thick. I find that's pretty good on the outside for squishiness for a TPU wheel. And then we need to get our center point. Now for our center point, I'm actually going to make this rather than offsetting from the top, we always want a consistent diameter around the center. Let's say we want to think about how we're going to power this wheel. Typically, we might use a servo motor to power this. And a servo motor, if you were to put a circular horn on, is about 31-ish millimeters. So I'm going to go ahead and grab a circle. And just so we get a little extra clearance here, I'm going to make this 32 millimeters because we're going to get a little bit of thermal expansion when it comes time to 3D print things. Basically, if you were to 3D print this at 32 millimeters, you're not actually going to get 32 millimeters. You actually get slightly smaller by about 4-ish%. So depending on the type of filament you're using, this should end up being a pretty good width for us. So now I've got a lot of air space that we can work with to be able to make our compliant wheel. And actually, now think about this 32 wheel here, I'm actually also going to make an offset off of this by, say, 5 millimeters so that we have a nice kind of thick chunk inside ring that we can work with on our wheel. So let's go ahead and actually make these slots. I'm going to grab this line tool and I'm just going to grab from my first line here down to my second line. Off of this line here, we're going to go ahead and make a second line so that we can have our offset point. So let's grab another line tool, come up over here and just choose something randomly. Press escape to deselect. Now with this line, you'll notice that we can kind of drag it and move it around. But I want it to be equal length as this line. So up inside my constraints tool, I'm going to grab this red and gray lines for equal. And it's going to create these two and make sure they are both equal in length. So no matter where I go ahead and drag this around, it's always going to be equal in length here. And I also want to make sure that I have a consistent section between them. So I'm going to grab my dimension tool, and I'm going to select both lines so I can have a consistent angle between them, and I'm going to say a 20-degree angle. I found that a 20-degree angle fits pretty well for the amount of a compliant wheel based on TPU here. So now I've got my little offset cut, I have my extensions, and I am ready to rock on this sketch. So I can go ahead and finish off the sketch. If I go into my bodies now, let's go ahead and extrude this center point. We're going to go ahead and look to the other side. If we were to grab our arrow here, we're going to drag it through our body. But rather than drag it all the way through, again, on the right-hand side of this extrude panel, if you remember, if we were just to cut it to 25 distance, we want to change the length of this. It's actually going to end up cutting into other features, or it's not going to go all the way through. So instead, we're going to say to object, and we're going to select the top face so that it always cuts through no matter how thick we make that object. We'll go ahead and click OK. And now we've got our feature cut through. So let's go over ahead and pattern this. In lesson 2, we learned about the rectangular pattern feature. There is also a circular pattern feature. So for this circular pattern, rather than selecting bodies, I'm going to select features. I'll go ahead and select the extrude 2 here. And then for my axes, I can go ahead and select the outside ring of my circle, or I can select the Z axis itself. And you notice that it's going to create this pattern all the way around. Now underneath here, I can also select distribution, where I only want, say, a partial section of this. So rather than going all the way around, I could say do this only for 180 degrees. Or I want to say do it for 315 degrees. If you want part of a circle to be a rectangular pattern, you can go ahead and do that. For our case, we're going to go ahead and make it full. And then we're going to go ahead and find something that looks about right for the amount of squishiness that we want. So I'm going to go ahead and put in about 14 sections. I think that looks about right in my thickness. For our compute type, again, I'm going to select optimize. That makes life a little bit easier on your computer, depending how complex this is. Now I want to see how thick these walls are. So let's go ahead and grab our inspect tool. We can select one edge and a second edge, and we can see what our distance is. We got about 2 millimeters. 2 millimeters is pretty thin as a connection point. So I think I'm going to go ahead and make those connection points a little bit thicker. So let's go ahead and edit this back, and I might reduce off, say, 2 of those sections. So now if I were to grab my inspect tool again, I can grab one edge and a second edge. Now I've got 3.5 millimeters. That makes me feel a lot more comfortable about the amount of squish or compliance we're going to have inside this wheel. Now before I go any further, let's go ahead and go back, and I've forgotten to rename my bodies and rename our sketches. So for this sketch number 1, I'm going to go ahead and rename this as the main cylinder. And the sketch number 2, I'm going to go ahead and rename this as the compliant cutout. Now I did make a bit of a mistake here in that I forgot to start with making a component. So I'm going to go ahead and because this is our first design, it's going to be a multi-component part. And when I mean a multi-component part, it's basically going to have multiple bodies or parts associated with it. We have this outside section, and we have this inside insert section. So what we're going to, so in order to be able to keep those components separate, in Fusion, we break these up into components. So in body number 1, I'm going to right click and I'm going to select create components from bodies. And I'm going to go ahead and rename this, and I'm going to call this one the compliant wheel. Now, typically you want to start your designs with creating a new component from the start. So you would typically want to go say new component. We're going to call this component 2 the insert. And now we have 2 components that we're working on. As I create a new component, you'll notice that we have an active component and an inactive component. If I were to go ahead and select this little circle here, it would make this active, and our other component would end up being hidden, so we know what component it is that we're working on. If we're to select this top thread here, it means we're looking at this main part. So if I look at this component wheel, you notice that our timeline kind of disappeared. Again, this was a mistake that I made in that now my timeline is related to this main active part. So if I can come inside and work on this insert, you'll notice that I only working on a brand new timeline, and none of those other features show up because those are part of my main timeline. So let's go ahead and actually make that insert here. The problem is if we were just take a polygon and put it through this wheel and try to rotate that axle, it's actually just going to shred that TPO out and you're not actually be able to spin that axle. So we're going to make a hard plastic insert that's going to fit inside. So let's go ahead and create a new sketch. And on this new sketch, we're going to go ahead and create this on our XY origin. We're going to start with creating a polygon. I'm going to make a circumscribed polygon in the center. And for the Go Build pattern, it's 7 millimeters to the start. So I'm going to make this 7.1 so that it's actually going to be 7.1 divided by 2. We'll make it 7.2 divided by 2, so it's a little bit larger than the actual axle will be, so it should slide in nice and neat. And then now we've got our polygon here, we're actually going to make our insert around it. So let's go ahead and grab a circle. And we might make this circle something like, I don't know, 15 looks about right. So let's say a circle of 15. And then we can't just take the circle and just mesh it through. We want to add some sort of keys to this. So on this point, what I'm going to do is I'm going to go ahead and add in just a little key jet out on this point. So working off of this, I'm going to go ahead and draw in a center line. So I'm going to grab my line tool, make it a construction. We're going to make this line, say, 4 millimeters up. Then I'm going to grab my line tool again, get turned off by construction line. We'll come out by 2 millimeters. Oops, not 20. We'll come out by 2, and then we'll come down until we coincide with this bottom tool there. We'll go ahead and mirror these over with our center line. And now we've got a face that we can pull together into this center circle. So now we're going to go ahead and extrude out this main kind of center hole. So I'll press E to open up my extrude tool, grab my center point. We'll go ahead and drag down, and our distance is going to be to object, and we're going to select to the bottom of the compliant wheel. Now this is a new feature that we've used in that we're not joining any bodies because there's no bodies to join. And we're not cutting in any bodies either. We're actually going to create a new body inside of this extrude. So we'll go ahead and select OK. And now we want to join our other section here. I'm going to go ahead and open up the insert section, and we're going to go ahead and show this initial sketch again. We're going to grab our extrude. Again, we're going to say to an object, and we're going to say to the bottom of this piece that we just made. And rather than join, we're going to also make a new body. The reason we're going to do that is we want to circle pattern this around. So this can be a key that we're going to cut in. If we were to join this, we would not be able to reference this as a different feature in our timeline to be able to work around. So I'll go ahead and select OK. Now we can go ahead and hide our other sketch. And we will create a rectangular pattern. Or sorry, circular pattern. Select our object, select our axes, and then we will maybe make it 5 on the inside as a nice little keyhole. So that as this wheel spins around, it's not going to pull out of our wheel. And actually, you know what? I might make it 4. 4 might have a bit of a stronger connection to be able to hold in there. We'll go ahead and select OK. Now, to make sure these are all the same piece, we're going to learn about a new tool here called the Combine tool. The Combine tool allows you to bring bodies together into a solid piece. So my target body is this center piece here. Oops, not this target body. My target body is this center piece here, and my tool bodies are this outside keys that we just made. I'm not going to select Keep Tools, because right now you'll notice that I have 5 bodies selected. If I were to select Keep Tools, it's actually going to keep an individual copy of all these bodies and put it all in. I'll show you that in a second. I'm not going to make a new component because this is going to go in, and then we can either join or cut or intersect specific sections. So I'm actually going to go ahead and select Join and select OK. And now you'll notice I only have 1 body. If I were to go back and edit this and say Keep Tools, you'll now notice that I actually have the main body and all of these individual subbodies and this main body itself is now combined with those 5 small subbodies. So instead, I'm going to turn off keep tools, and now we only have one body at this point. So now comes the time where if I were to look at my whole piece, I now have my center cutout and my compliant wheel, but my insert is not actually cut out of my main shape. So I'm going to go back and make my compliant wheel my active component, and I'm going to select the combine section. My target body is the body I want to affect, and the tool bodies is this body here. Rather than join, I'm going to go ahead and make cut so that it actually cuts through my body here. I'm going to go ahead and keep the tools because we don't want to delete the tool body, and we'll select OK to finish this off. It's doing its computing, and now inside, if we were to hide our insert, we now have our section cut out. But you notice we got 2 bodies. So underneath body number 2, let's go ahead and remove body 2. You don't want to delete it because that's going to end up causing some issues on the way back. You should typically remove things if you can. So we'll remove it. It's going to compute it with your parametric timeline as time goes by. Now, if we were to 3D print this as it currently stands, these 2 pieces have micromillimeters between them. Very, very small gaps between the 2 of them. So we need to make sure we add a little bit more of a gap. So I'm going to go ahead and hide this insert, make my compliant wheel my active component, and then I'm actually going to take all of these faces and I'm going to back them up just a little bit. We can do that using the offset face tool. Alternatively, you can also press the press pull command, and Fusion is smart enough to know that you're wanting to offset this face. So I'm going to go ahead and select all the faces inside of this keyhole insert. We're going to offset them back by, say, minus 0.2 millimeters. If you were to, say, get the CNC'd out, you wouldn't have to do that. But because we're going to be 3D printing this, you want to leave a little bit of extra gap because this piece is going to expand and this piece is going to expand. And that should be able to get you just enough clearance so you should be able to force this point into your wheel, and it should be a nice tight fit. Now, if we were to zoom out and look at our main component here, the last thing is it's not very obvious to know these 2 differences apart. So if I were to go back to these components and I press the A key on my keyboard to open up appearance, Fusion has a lot of different appearances we can work with. I can search for rubber, and you may need to download it. You can go ahead and drag a rubber onto your component. And then on insert number 2, I can also go ahead and press appearance, and maybe I'll search for yellow. And I might just grab, a plastic matte yellow, go ahead and click download it from Fusion, and we'll go ahead and drag it on so that when I come back to my main view here, I now have 2 separate pieces, and it's very obvious to tell what specific sections of my components are. So I hope you learned a little something today about continuing working through that extrude tool, offsetting faces, the combine tool, a little bit more with sketches and circular patterns, and then as well how we can set up our objects properly using components. In the next tutorial, we'll learn about the sweep tool to be able to make a boot kicker to be able to also bring in some more objects into our robot. So I will see you in the next one, and best of luck on your next robotics project.